Okay, finally, here it is. Building the Wolverine amplifier, wiring your amplifier. In this video, where we left off, updates and tweaks, safety notes, some layout ideas, some power supply information, how to wire your amplifier, tips and tricks for low noise, tips and tricks to avoid ground loops, tips and tricks to avoid hum, discussion on loop area and the advanced grounding guruship document, an actual measurement of noise using test equipment and a listening test. Where we left off. In the previous video, I had discussed the distortion performance of the Wolverine. Some time has passed since that video, and as it turns out, the THD level has been measured at even lower levels using an E1DO Cosmos ADC, Victor's precision oscillators, and an APU notch filter. The precision oscillators were even powered by a lithium battery pack to ensure there was no mains noise present on the source to the amplifier. Amazing efforts by Andy, Fire Animal at DIYaudio.com, and you can see these measurement results at the Wolverine build thread on DIYaudio.com. Updates and tweaks. If you want to have a bit of fun modifying your Wolverine amplifier, there are a few tweaks you can apply. There's a small modification to the feedback trace to improve distortion levels. There's a VBE multiplier modification which has improved the thermal performance of the amplifier. There's also the option of a 10 kilo ohm input impedance for lower noise if you like. Please check out the DIYaudio.com thread and the build guide if you would like to make these modifications. Before we get started, I need to talk about safety. If you're not qualified to work on electrical equipment, please ask for help from someone who is qualified. Amplifiers can be dangerous or even lethal to work on if you're not qualified and experienced. Since this video may be watched in different countries, please refer to your local electrical regulations on this topic. Amplifiers contain lethal voltages. You have been warned, and it's your responsibility to look after your own safety. The first step, and one of the most important steps to consider, is the amplifier internal layout. At this point, I hope you have chosen a nice spacious chassis with reasonably large heatsinks, and your amplifier modules are working and ready for bolting into the case. This is the step where the temptation is to rush just to get the amplifier going to listen to. People often get excited and don't do a neat job at this step. I would encourage you to take a little time to think about this step and plan how you're going to lay out your amplifier. Have some fun and play around with some layout ideas. Move some things around to get the best fit. Get your transformer or your switch mode power supply and trial fit it in the chassis. Maybe you have two transformers you want to use, one for each channel. How are you going to arrange them? Where are you going to put your control boards and power supply capacitors, for example? Check that you have enough clearance for all the parts before you start bolting things in. Have a look at some nice looking designs from high-end manufacturers to see what sort of options there are when it comes to layout. A Griffin amplifier, for example. Note the capacitor bank and the transformer location. Note the relatively short shielded input leads. A Class A branded audio amplifier, for example. Note the transformer location, kept away from the input terminals, the twisted speaker leads, and the relatively short power supply connecting leads. A Parasound JC5 amplifier designed by John Curl. Note the shielded transformer and separate input stage power supplies, and how close the large power supply reservoir capacitors are to each other. The famous Howcrow amplifier. It uses a power factor corrected switching power supply seen at the bottom of the picture and separate enclosure for the audio circuitry towards the top of the amplifier. Note the output network and its large inductor, a beautiful piece of engineering right here. Apparently there is an air-operated power switch. Please note the tightly twisted wires going to the power supply reservoir capacitors in the center of the picture. The Sim Audio Moon 700i V2 amplifier. Note the dual power supplies and exceptionally neat layout here with very little stray wiring at all. The Pass XA25, a reasonably neat layout. An interesting use of ribbon cables in this one. Note the transformer location compared to the input connectors. The D'Agostino Relentless amplifier, very large power supply. Note the location of the transformer compared to the input terminals. The Topping LA90, a separate switching power supply module, is used for low noise. The Benchmark AHB2, note the separate switching power supply board sandwiched on top of the amplifier board. The Mark Levinson No. 536 amplifier, note the extremely neat layout. Finally, a Labgruppen FP10000Q, professional power amplifier with a switching power supply. Note the layout with the power supply on one half and the amplifier module on the other. The point of me showing you these amplifier internals is to get you thinking about the layout. You have some flexibility to arrange things to achieve the best result possible in terms of noise and hum. Notice how the layouts are for the most part neat and tidy without a lot of stray leads everywhere. Both switching power supplies and traditional linear power supplies can be used successfully, but the physical layout is important to keep unwanted electrical noise and hum down to a minimum. Here are a few simple suggestions to help you achieve low noise with your build at the layout stage. Number 1. Try to keep higher current wiring and power supply items away from sensitive higher impedance areas and wiring. For example, keep the power transformer or switching power supply unit away from the amplifier signal input leads, and keep the power wiring away from the feedback traces and input leads. Use a shielded toroidal transformer or metal screen switching power supply unit. Regarding toroidal transformers, if you can afford it, use a potted one with a flux band, exterior metal shield and electrostatic screen. A potted transformer helps to minimize mechanical noise and hum. Try to arrange your boards, modules and anything which requires wiring inside your case so that the wiring is as short as possible and the loop area is at a minimum. More on loop area later. Number 4, try not to run any signal leads over the transformer or close to the transformer wherever possible. I like to twist and heat shrink leads exiting the transformer so that there is not a loop made. I like to twist each winding individually, and generally I use one bridge rectifier per winding. Just as a side note, at the end of the build you may need to turn the transformer to find the lowest noise orientation with respect to where the leads exit the transformer. Just something to keep in mind. You have a few build options available, such as monoblocks, which are a single amplifier and power supply per chassis, a stereo amplifier, which is typically 2 amplifiers with a single power supply per chassis, dual mono, which is 2 amplifiers, each with its own individual power supply in one chassis. Sometimes people use a single transformer with 4 output windings to allow individual diode bridges and capacitor banks for each amplifier module in a stereo amplifier. This is another good option. I'm using dual mono configuration for my build in this video. You can see how I have arranged the toroidal transformers to attempt to keep the wiring down to a minimum and cancel the magnetic fields to some extent. Cambridge Audio has used a similar approach recently. The general idea is shown below. Is this idea marketing hype? Well, you can judge for yourself later on in the video. You can see I'm using one amplifier module with the output transistors pointing up and one with the output transistors pointing down. The reason for this is to keep the output leads short and the higher current leads for the power supply and speaker output away from the feedback trace side of the PCB. This also minimizes loop area and keeps the transformers outside of the wiring loop areas. If you create a loop around the transformer with your wiring, you risk hum pickup. Let's talk about what building blocks you need and then how they're wired together. I'm going to give you a picture of how all the pieces of the puzzle fit together so you conceptualize the overall system, and the basic idea is as follows. A power lead connects to a power inlet module, which connects to a soft start control board, which connects to your transformer, which connects to your rectifiers and your capacitors, which in turn connects to your amplifier and then to speaker protection if you're using protection, and then out to your speakers. Input wiring to the amplifier is also required, and an audio ground lift is useful to have. Let's go over some basic power supply information. Domestic audio power amplifiers are usually powered by the mains. In general, most countries have a nominal mains voltage of either 110 to 120 AC RMS volts at 60 Hz, America for example, or 220 volts to 240 volts AC RMS at 50 Hz, Australia and Europe for example. The nominal voltage where I live in Australia is 230 volts AC RMS, which allows some voltage tolerance depending on the load variance. Normally, power is distributed to your house via overhead power lines or an underground cable. Once it reaches your house through various pieces of switchgear, voltage transformers and other infrastructure, it arrives at your meter box. Here's a picture of the basic idea. Inside the meter box, typically there are circuit breakers, a main switch, a residual current device or RCD, and power metering so the electricity company can bill you. The meter box has a very crucial connection for your safety, and in Australia it's called an MEN point, which stands for Multiple Earth Neutral Point. This point is where earth and neutral conductors are connected together in order for your RCD or residual current device to cut the power off from a circuit in the event of certain types of electrical faults. The way this works is a tiny current transformer inside the RCD compares current flowing in the active and neutral conductors to current flowing in the earth conductors in your main circuits in your house. If there's a large enough difference, typically 30 milliamps, the RCD will disconnect power to that circuit within approximately 30 milliseconds, hopefully saving your life. Here is the MEN point, which is the green and yellow thick wire between the brass, neutral and earth bus bars. Note the wider devices on the DIN rail pictured here are the safety devices commonly called an RCD or residual current device, or safety switch. I won't dig too deep into this topic, but the reason I'm explaining this to you is so that you understand the importance of the mains earth connection and also what people mean when they use the term mains earth. If it helps to picture it, when you think of mains earth, there is a connection to the actual earth or dirt next to your house, in the form of a large copper-coated steel ground stake. Here's a typical mains earth connection to a ground stake in Australia. This is mains earth connected to a ground stake. This is not audio earth. The reason I'm showing you this will become clear later on when we go over the mains earth connection in an amplifier. Now that we've briefly discussed the power supply to the amplifier and the importance of the mains earth, let's start going through the process, starting with the power cord. Below is an example of an Australian power cord set. You don't need a particularly fancy power cord like below, even though they look nice. But there are two important things to consider. The first thing to check is please make sure your power cord has an electrical safety approval for use in your country. Ordinarily, there will be markings on the plug face and cord sheath. The second thing to check is the cross-sectional area of your cord, listed in millimeters squared, is adequate for the power supply in your amplifier. In general, 1 mm squared to 2.5 mm squared cables are used in Australia for cord sets, since the mains voltage is 230 volts and the maximum current from a single domestic outlet is 10 amps. In the USA, you might find that a larger cross-sectional area cable is required due to lower mains voltage, since a larger current will be drawn from the mains for the same given power output. So now that you've chosen your very fancy and expensive power cord set, which has electrical approval markings for use in your country, the next thing to consider is the power inlet module. There are many types, so choose one suitable for the voltage appropriate for your country. Refer to the manufacturer datasheet for this information. Please also check the inbuilt power line filter has a large enough current rating for your amplifier build. I like to use a power inlet module with a built-in switch, fuse holder, line filter, IEC socket and 6.3mm spade terminals, since it's neater and more convenient. I usually use the Schaffner FN9290 or similar types. However, in this case, I'm using a Schurter type like the left-hand picture. Don't forget, no power cord is to be connected at any time until you have completed all the steps to get your amplifier working. And if you're not a qualified electrical worker of some sort, you must get someone qualified and experienced to help you and check your work before power on. That being said, the first connection to make to the chassis is the earth connection. This is the connection which allows the RCD safety device in your home switchboard to operate in the case of a mains fault to chassis earth. This is an extremely important connection and requires special care and attention. Please notice the earth connection is immediately made at the chassis. I've tilted the back panel so you can see the yellow and green wire directly from the inlet module to the chassis base plate. Please also notice the star washers on the inlet module screws. Please see the star washer which I use for making earth connections. These washers help to make a solid chassis earth connection which is shake resistant. These washers are also excellent for using on anodized aluminium, since they cut through the anodizing and make a solid electrical connection. Please see below for an example of a star washer use when making a chassis earth connection. Make sure to use star washers at your chassis earth point. Do this nut up nice and tightly so the star washers bite into the metal and the crimp lugs, ensuring a very solid connection. The next connection is the mains connection from the back of the power inlet module. Please use appropriately rated cable for your country. I like to tightly twist all AC mains wiring and heat shrink or use sleeving over the wiring for some mechanical protection and another layer of insulation. This is of particular importance with the mains leads. The mains leads are blue and brown in this case. Blue is neutral and brown is active. Red is also active in Australia for fixed mains wiring and neutral is black. Green and yellow is for mains earth. Please use high quality crimp connectors and please use high quality crimping tools, since cheaper crimpers make a dog's breakfast out of the crimp connection. In a pinch, the style on the left works, but the ratchet types work a lot better, although they can be a lot more expensive. As the saying goes, buy once, cry once. The mains wiring will next connect to your soft start module if you're using one. This module is to stop the main circuit breaker tripping out due to the large inrush current which happens at turn on if you have a large transformer and capacitor bank in your amplifier. Below is an example from the DIYaudio.com store. There are a few different types that people use. There are also more advanced options available, some with software control, speaker protection, overcurrent protection and thermal protection features. Here is the control board I used. Generally, these circuits use some kind of relay arrangement with a power resistor or resistor bank or an NTC thermistor. The idea is to reduce the large peak current which occurs at startup due to the hopefully large mains transformer and hopefully large capacitor bank. The transformer comes next, and its primary winding is connected to the output of the soft start board. Pay attention to the transformer datasheet and soft start instructions for the wiring layout and configuration. It is also worth noting, please avoid making a shorted turn on your toroidal transformer when bolting it into your chassis. Relatively large currents can be developed in the case of connection style B, pictured here. So please avoid an accidental shorted turn. These mounting options avoid the shorted turn issue. If you can avoid bolting things like bridge rectifiers and connectors to the top plate of the transformer also, since this is an opportunity to pick up magnetic fields and hum. The next connection is to the bridge rectifiers and capacitor banks. You can use chassis mount capacitors or board mounted capacitors, whichever is convenient for you. Please ensure you have a large enough voltage rating. Consult the build guide for your amplifier, and there are plenty of nice options available. You can see inline bridge rectifiers in this example. This is where the power transformer secondary windings connect to. Consult your power supply datasheet and transformer datasheet. The next connection is on the other side of the power supply board, which is connected to the amplifier module. This point also has connections to the speaker protection modules I used and the ground lift modules that I used. Here is an excerpt from the document How to Wire an Audio Amplifier, which shows the order to connect to the power supply 0 volt point. I will link to this document, and also this document is provided in the Wolverine Dropbox. Here is an example of a T-ground PCB which shows the order to connect the grounds. The ground lift module I mentioned earlier is used to connect the amplifier DC power supply 0 volt point to the chassis earth. The chassis connection for this module is the same point at which incoming mains earth connects to. The ground lift board connects to the amplifier DC power supply unit 0 volt connection to the chassis earth through a simple circuit using a bridge rectifier and an RC filter. Here is a picture of the ground lift board I used. I like the terminals and it's nice and neat. You can use a regular 35 amp bridge rectifier and connect to that with success also. Please notice there is a terminal which connects to the chassis earth point and another which connects to the amplifier power supply 0 volt. This circuit lifts the audio earth from the mains earth potential slightly in order to reduce the main earth noise on the quiet audio earth. At no stage does this board remove the mains earth connection to your chassis. Here is the basic diagram. There's an excellent article on this topic on the ESP Audio site where this picture is from. Here is how the earth loop breaker fits into the equation. Please notice how the metal chassis is immediately connected to mains earth as soon as it enters the chassis. I used one ground lift board per amplifier since I have one power supply per amplifier. Please use a 35 amp rectifier for this location in case of a fault. Please use an X2 rated capacitor, which is mains connection rated. Please use star washers for the terminal connections. I like to crimp and then also solder these connections throughout the build for a low resistance connection. This may be overkill. I like to use either silicon insulated wiring or PVC insulated wiring, preferably with reasonable temperature rating, since things inside an amplifier can run warm or even hot. I like to twist the wiring reasonably tightly with a cordless drill and then cut it to length as needed. You don't need extremely thick wiring. It's more appropriate to use wiring which is rated correctly, allowing proper sized terminations and routing within the amplifier. In fact, a small amount of inductance, capacitance and resistance in the leads connecting the amplifier to the DC power supply boards may be beneficial in terms of some small amount of filtering of power supply ripple and noise. I used 14 gauge wiring for the amplifier DC rails, which is approximately 2.5 millimeters squared for people using the metric system. I chose red for the amplifier positive DC rail, blue for the negative DC rail, and black for amplifier 0 volt DC. I covered this in braided sleeving for some mechanical protection and heat shrunk the ends. Here you can see the ground lifts installed in the chassis on the base plate. You can see there is a connection to chassis earth from the two transformers for the interwinding electrostatic screens. Let's take a small diversion to talk about reducing noise generated from the power supply. When you rectify AC to convert it into smoothed DC, the diodes used generate switching noise in the form of short, high current pulses as the power supply reservoir capacitors are charged. These pulses can cause ringing in conjunction with the transformer lead inductance, and this is part of the reason to use a T-ground to keep connections away from the high current charging pulses directly between the power supply reservoir capacitors. There is a jig called Quasimodo detailed on the DIYaudio.com forum which you can use to damp this ringing by adding snubbers to your power supply. The jig is pictured below connected to one of my transformers. This is what ringing looks like. See the yellow pulse simulating the diode and the blue oscillatory waveform. The blue waveform is ringing. With Quasimodo, the bell ringer, you can adjust the values using low voltages to find the optimum snubber values to dampen this ringing. Then you solder these parts directly to the bridge rectifier location on your PCB. Here's the result of snubbing the rectifiers. It doesn't hurt to test your power supplies without the amplifier boards connected at this point to check everything is working. Make sure you disconnect the power supply and wait until your power supply capacitors are completely discharged before continuing the build. Let's continue the wiring journey. From the DC power supply, you connect to the amplifier modules with your tightly twisted DC power supply leads. At this point, it's worth noting a tip. Try to keep the wiring loop areas as small as possible by pointing the connectors together. Although not strictly required, if you're able to use them, some nice machine spacers for this purpose can really keep this area tight. The next connection is the speaker output connection, and I would recommend once again keeping these connectors close and twisting the leads tightly together. I went as far as making a little aluminium bridge to separate the power supply and speaker wiring from the side of the amplifier board which has the feedback trace on it. Credit to Stuart from the Wolverine team for this idea. The power supply and speaker wiring have high currents flowing in them during use. The feedback trace has relatively low current flowing in it during use and is relatively sensitive. Note my gratuitous use of star washers. So see how the input wiring, speaker output and power supply wiring are now relatively separate using this technique. I like to measure out the cable lengths before the case goes together, leaving some extra for terminations. Piece by piece, things are coming together. I covered the silicon insulated wire with braided sheathing and zip tied it to cable retention clamps to keep things neat. I found this helped a lot during assembly in the chassis. Continuing, the next connection is to the speaker protection boards. Pictured is a nice board available from the DIYaudio.com store. Here are the boards I used, which mounted on the speaker terminals. Be sure to twist the speaker leads which connect to the speaker protection boards. I used 14 gauge silicon insulated wiring for the speaker wiring. The boards I used have MOSFET switching instead of a traditional mechanical relay. Once again, there are many suitable options available. At this point, I also added a connection for the 12 volt trigger on the soft start / amp control PCB. The next connection was the input lead. Initially, I used RG316 coaxial cable, but I have since changed the signal input lead to Canair twisted pair with shield. This is how I prepared the lead. Trim the leads to length and then strip them. I decided to use crimp-on ferrules to capture all of the copper strands. Solder is not ideal when you use it under a screw terminal since it deforms under mechanical pressure. I heat shrink so it's nice and neat. The loop area and length is kept to a minimum where the conductors exit the sheath. I'll connect the shield at the amp input connector end. Keep the input lead secured away from the power supply and speaker leads as best as possible. I quite like these cable retention clips to keep things neat. At this point, I prepared all the ancillary control gear connections. There's over temperature and over current sensing options on some control boards. I bolted the temperature sensors towards the center seam in my heatsinks. I ran a lead to the power switch. This was also twisted tightly and heat shrink was used. No surprises here. I'm using a low voltage momentary switch with red illumination. It runs from 12 volts DC from the control board. Don't underestimate drilling the hole in the 10mm thick front panel. It took some care not to butcher it. It's a good idea to check that things are working before final assembly. And you can see the 12 volt DC trigger connection next to the power inlet module and testing out the illuminated power switch. I went over all of the connection and terminations to make sure they're neat and firmly connected. At this point, it was time to bolt it all together. As a tip, I'd recommend using star washers on every panel so there's a good connection between all of the metal panels for safety reasons and electrical noise reasons. With the DIYaudio.com store aluminium cases, a 450mm long screwdriver helps a lot. It also helps to have a magnetic tip so you don't drop screws inside the case and then swear profusely. In fact, I'm not sure how to assemble one of these cases without a mega long screwdriver. Notice how hard it is to get in from behind the front panel. A 450mm long screwdriver makes short work of this. Make sure to use star washers on the back panel for a good electrical connection. Don't do what I did and install your amplifier modules upside down, because you need to be able to set your bias when the amp is together with the lid off. It takes a long time to pull all of this apart and turn the amp modules up the right way and repeat the process. I hope this gives you a laugh at my expense. Please learn from my mistake. Now that you've built your amplifier twice, it's a good idea to rebias with everything in the case. Underneath the amplifier, I like to use star washers also. Make sure the anodized panels have a good electrical connection. This will help to reduce electrical noise, and it's also important for safety reasons. Okay, that concludes the wiring part. Along the way, you may have picked up on the tips and tricks. Let's go over tips and tricks for low noise. Use a power inlet module with a line filter. Use twisted leads for your wiring. Use a shielded power supply transformer. Consider carefully turning the transformer for lowest noise. Keep power and signal wiring separate. Keep high current and low current areas separate. Use star washers to electrically connect the panels. Here are some additional tips. Use a 1 nanofarad ceramic capacitor from the RCA input connector shield to chassis at the input point to minimize RF ingress. Use clamp-on ferrite cores on the speaker leads, power leads and input leads. Consider a balanced input board. Let's revisit the tips and tricks to avoid ground loops. First and foremost, plan your layout to keep the transformer outside of the wiring loop for both signal and speaker leads. This could be the single most important step to take. Don't run leads across the power transformer. Don't have multiple chassis earth points. Do keep your input connectors close together so there's no loop formed with the incoming signal leads to your amplifier. Practically, I've not had an issue with this, but it's good practice to keep the inputs close together. Let's go over the tips and tricks to avoid hum. Have one mains earth connection immediately as the earth lead enters the case for safety reasons. Use a potted transformer with a flux band, electrostatic shield and shielded case. Use a ground lift for your audio ground connection. Use the T-ground method described in the Advanced Grounding Guruship document, which I'll link to. Don't connect the RCA input connectors shield to the chassis. Do use an amplifier module with hum breaking resistors built in, like the Wolverine amplifier. So, quick discussion on loop area and the Advanced Grounding Guruship document. I would highly recommend everyone reads this document, since loop area as a concept is not immediately obvious. The light green shaded area will give you an idea of what I mean by loop area. Notice that the transformer pictured is outside of the shaded loop area. We want to keep the transformer outside of this area and keep this loop area as small as possible. The How to Wire an Amplifier document goes into a lot more detail, and I would recommend reading it. Please see basic examples below and notice how the toroid is kept out of the loop in the right hand side example. After all of this, what sort of noise is on the output of the amplifier with a shorted input, and can you hear it? Straight off the bat, there is no audible noise on the output with ordinary speakers, so the listening test is pointless. The measured amount of noise is shown below. Notice the largest spike is at approximately 18 microvolts. The set of measurements below the 100 nanovolt line on the graph is the noise floor of the measurement equipment. In terms of a useful measurement of noise, we need to define the measurement bandwidth. So here is the FFT from 20 Hz to 20 kHz. I've put a red arrow at the 10 microvolt line on the graph. This was measured using REW directly into an E1DA Cosmos ADC without attenuation. I've zoomed in so you can see what it looks like. References used in this video include Designing Audio Power Amplifiers by Bob Cordell, Audio Power Amplifier Design 6th edition by Doug Self, High Power Audio Amplifier Construction Manual by Randy Sloan, and How to Wire an Audio Amplifier by Andrew Russell, which is the advanced grounding guruship document I'm talking about. Earthing Your Hi-Fi Tips, Tricks and Techniques from sound-au.com. Bill Whitlock's presentation on grounding. And also a big thank you goes out to the Wolverine Amplifier team. I hope you found some of this information useful and enjoyed the video. Thanks for listening. Now it's time to listen to and enjoy your amplifier.